So what I've got here is just a simple bracket arm for a mount. And if we slice it, I've already sliced it once, we can go through, and if you look, I have pulled down this infill and I have set it to 5% for right now so that I can show you guys a little bit about infill. Now if I drag this down, this is the gyroid infill, and we're going to go in and change it here in a moment. But the reason that I like the gyroid infill is it is a three-dimensional infill pattern, and if you look, while I'm building layer height, it is actually morphing around and it creates a three-dimensional shape that goes in lots of directions in there, and it's almost like a foam fill. It's not a honeycomb, but it's like a uniform foam fill, if you will. It does really good. It gives really isotropic properties to your parts. They have the same type of strength this way as this way and vertically as well. Um, so I'm a pretty big fan of it. Um, that is one of my go-to infill patterns. um, One of the biggest things that I like about it is that it's very fast to print. It does a really good job printing very quickly, and anytime I can take time out of a print, that's something that I will normally do if it's not going to sacrifice strength. So if I wanted to change the infill pattern, one of the ways that I can do that is I can go up here to the print settings button, and I can go down to infill, and under here we have the print pattern or the fill pattern, and you can pull down, you can go through some of these. The two that I'm going to really cover are rectilinear and the gyroid. I can reslice that, and the rectilinear, what you'll see is it's basically just straight lines. It's kind of like a grid. um, this is a pretty good it's a pretty good infill pattern. Um, the If you look at grid, it is going to look almost identical. There is a little bit of difference there. Um, if you come back and pull down to rectilinear and slice it, the rectilinear puts more boundary on here, and it's also a finer fill rate than the grid is. Not really sure why they decided to do that like that, but if we step this up to a much finer fill rate and we look in there, you can really see that the rectilinear starts to just look a lot like the lines like that right there. A you get a crisscross pattern of alternating lines, and the grid, on the other hand, it actually will just build straight up boxes like what you saw before. So, I mean, there is a difference between them, and at the finer infill settings, as you go higher and higher infill, the rectilinear starts to look more like that. This is a perfectly fine infill pattern. Uh, I usually will print it at the finer settings like this. Um, a neat sidebar is that if you slice a rectilinear at 90%, it's going to appear basically solid. It's technically not solid. and the lines actually don't connect, but you can actually get better material properties um, with a 90% infill. And it seems counterintuitive, but there are certain material properties that you can get at 90% infill that actually make the part a little more compliant. Um, so that's something that I plan on going through a little bit later on. But you can normally print with relatively low infill ratios to save time and plastic, to be honest with you. And you can see if we go back into these low infills, it goes back to being the same as like what the grid is. Um, for the cubic infill, this is one that I used to use and still do from time to time. It's kind of a triangular, three-dimensional infill pattern. If you look, it's kind of building this three-dimensional, almost like pyramid kind of a shape down inside of there. It's it's a little tricky to see it build until I can get the shadowing right. But if you watch the it's it's building this three-dimensional triangular pattern through there. Uh, this is another infill that I'm fairly happy with as far as material properties goes, but it's slower to print than the gyroid is. Um, this just prints much, much, much faster, and this is at 15%, which is not very high infill settings, and you can see how densely that's packed in there, and you can see how it creates this like almost like foam core type of effect down inside the material, and you get very uniform material properties in all directions just because of the way that it's formed, and it's the material lattice down in there lays down and it prints very quickly. For a part this size, unless I just needed it to be extremely strong at 15% like this, might even be a little bit dense. I would choose to go with something probably about 10% if I needed it to be pretty strong, and I would just up the perimeter count, and that's going to be the next thing that I'm going to talk to you about. So let's change this to 5 so that we can see what's going on inside of there. And so this is pretty coarse. We can see that there's a lot of air inside of there, and if we're not going to see a lot of load on this bracket, then something like this might well be what we want to do just to save on weight and plastic and print time. But if we needed to increase the strength a little bit more on there, what we can do is go in and edit the perimeters. So we'll go up here to print settings, we'll go to layers and perimeters. And if you see right here, the next thing down is vertical shells, and we can adjust the number of perimeters. So if you look as we increase this, it will change this down here, and you can see how wide each thing is. And so we can see where it says, this is a recommended object thin wall thicknesses, but this is just a good reference for you down here, this little bit right here. A lot of times For structural parts, I will go 3 perimeters about minimum, and a lot of times I will step that up into the 5 perimeter realm if I really want it to be pretty strong. And we can go back and we can slice that. And compared to the part we had before, you see these much thicker outer layers now. And this part is loaded here and here with a bending moment. So I've got a load pulling down here, and then this guy would be fixed. So the bulk of the load is going to be taken on this surface and this surface. Now, you guys haven't taken solids and materials and stuff, but the bulk of the load, whenever you're doing any type of part loading, the maximum happens at these outside edges. One will be in compression, one will be in tension, and the maximum is as far away as you can get, which is the outside edge of the part, which is why this method works. You can increase the material thickness on the wall, leave the bulk of the inside of it pretty much hollow, and we've just got some support structure in there just to help reinforce everything, and our outside perimeters keep the rest of the part strong. And likewise, some perimeters around holes and things reinforces those holes and stuff. And so we can see, if we went back up here, we could see that uh, 5 lines would be about 2 millimeters, somewhere in that neighborhood, which makes sense because of the settings that I have. So that gives us the wall thickness that we want. The other thing that we're going to need to look at is the top and bottom layers. And if you go here to layers, we can look at the horizontal shells, which is the top and bottom basically. And we can say, okay, we want a minimum shell thickness of this much, or you can go in and you can adjust this down. Now, your top layer is one that you're going to need to pay close attention to sometimes if you're using a low infill. If you just did one layer, let's go back here and look at the slicing if I did that. We're going to scroll all the way to the top. And if I back that down, oh, I set the minimum shell thickness. So we'll say that the minimum shell thickness is 0.2, just for right now. Reslice that. That'll allow me to have that. So if you see, it's only got one layer on top of that. If you look, if we get down there and look, it's going to be putting these layers across a lot of big open gaps. Like there's a piece of filament right there, and then there's a piece right there. And so if I look, that's a pretty long travel path. It's going to be in air and then catch right there and then be in air and then catch right there and then be in air all the way across to right there. And what you're likely to see with one top layer is that these pieces right in through here and right in there and some of those long areas like that, they're going to sag and it won't look right. You're going to see that gyroid pattern show through, and it's not going to be something that you're happy with. Um, so if you have these coarse infills like this, usually 3, um, that's why I had that set. I didn't set it. The default is 0.6, and that will be 3 layers there, and we'll go back and reslice it. And what that does is that first one allows you to do your bridging over the top of these pieces. So it's going through thin air a lot of times because it's just bridging over top of that. But then you have another layer that lays on top of those bridging layers, and then you have another layer that sits on top of that. And so by the time you get to that third layer, you've got something that is pretty well supported. And if you find that it's something that where you want a little bit more, you can just up that just a little bit more. You can do, 5 layers, something like that. Now, it does slow things down when you start to add those solid layers. If you have a big footprint on your part, you're going to see that it takes a lot longer because it's got to pack all these lines in there and it's just going back and forth, back and forth, back and forth. It takes a long time to do it. But you see, as I up that, there's one, two, three, four, five. And so that just gives you more of a chance to have a good top solid layer. And you can adjust the bottom layers as well. We can go down through the part. And your first layer is laid down like that. Your second layer, third layer, fourth layer, and then you've got your infill starting. So if we look back at the print settings, there it is, 4 bottom layers.